Okay, trying to get you ready for the cumulative test on probability. We can't possibly cover everything right now because we've just done this for like 3 weeks. I can't do it all in like 15 minutes. Not possible. But I can talk over some of the key ones that people had trouble with in the past. So the first test, one of the questions that you needed to know about for the first test was the area model of probability. Like, do you remember the one that had the circles? And trying to figure out the probability of hitting a certain circle? All right, let's call this circle A, this is B, this is C, and this is D. And let's say that A's radius is, let's say, 5, and B's radius is 6, C is a 7, and D's is 8. 5, 6, 7, and 8. So they just get a little bit bigger each time. Making sense so far? Okay, now, what's the probability? Given that I hit this thing, well, that means that it's going to be inside the D circle. So if it's given that I'm going to hit this thing, do you get that it's the total it's out of is the whole big circle? This is what is possible, all of it. So the D circle goes on the bottom, and it's an area, so it's pi r squared, right? So what's the radius of that D one? It's an 8. So it'd be pi times 8 squared. And 8 squared is 64. Do you get how I started there? All right, and some of you want to just watch me do this. It's not really going to work. So take out something to write with. It can be your iPad. And then get it to Notability. Or a piece of paper is okay. But I want you to be writing with me and doing a problem. Following along is comfortable and easy, but it doesn't make you learn as well. All right, I'm going to be asking you to billboard your answers towards me. If you're writing them on paper, every now and then you have to write it really big so I can read it. All right, so I just need a blank page in Notability. All right, here we go. So if this is, find the probability of, let's say, the hitting inside the C circle, or the C region. This is not an annulus question. An annulus would mean like a little shaded region like this. That's not what it is. Okay? We are talking about hitting anywhere inside C. So like if I said, if I hit right there, yes, I'm inside the B circle, but aren't I also inside the C circle? And if I hit in there, I'm in the A circle and the B circle and the C circle and the D circle. If my dart hits right there, am I inside the C circle? No. How about the D? Yes. All right. So, here's the question. Given that I hit the board, do you get how that makes this part right? Okay. Because given means I know for sure that's what it's out of. It's out of pi r squared, which is a D is 8, so it's pi times 8 squared, which is 64 pi. Given that I hit the dartboard, what's the probability I stay inside the C circle? Figure it out. And by the way, your pi's will cancel, which makes it way easier to divide. Lots less buttons to push. You'd want to get a calculator out and get a decimal. The whole test is round to 2 decimal places. Or no, 3, I think. 3 decimal places. All right, go ahead and divide and figure out what your answer is. Write it on your screen. Zoom in on it so I can see it really easy. Done? Before the end of the hour, remind me, I'll grade it for you. And I'll leave it out there. All right. I'm getting lots of points. 766. Tons of them. It probably is it. All right, let's see how you would have gotten that. You should have said, oh, it's pi r squared. But we know r. What's the radius for the C circle is 7, so 7 squared is 49. There we go. Now, how could they make this more tricky? What if they said, probability of hitting inside the A and B circle? Now, that makes it sound complicated, but if you think about it, if you're hitting inside the A and the B circle, then what are you really hitting inside? A. Because if you are hitting inside A and B, is A and B a big answer or a small answer? Small. And is a small answer, or is a big answer. If I'm hitting inside the A and the B circle, this wouldn't cut it, right? It's not hitting inside A and B. If I'm hitting in there, I'm inside A and I'm inside B. Okay? So if I said probability of hitting inside the A and the B circle, I'm really just in there. So that's really just the A circle. So you go pi, and what's the radius of that one? 5, so I go 25. Do you get what I just did there? A and B means really just A. Okay, now let's try another one where I want you to actually get the answer and put it on your iPad so I can see it. Would you please figure out the answer for probability, given that I hit the board, so it stays the same denominator, what's the probability that I hit inside the C or the B circle? C or B. C or B. Okay, so say I have a dart and it hits right here. Is that inside C or B? Yeah. Let's say it hits right here. Is that inside C or B? Yeah. Say it right here. Is that inside C or B? Yeah. Remember, or is a big answer. So it's all that put together. So that's really all put together. It's just what? Just C. If you could win hitting any of those, then this is the area we're talking about. So if I say or, it's a big answer. If I say and, it'll be a small answer. All right, so it's really just circle C. So then C is pi r squared, except it's 7, so it'd be 7 squared, so it'd be 49. There we go. Any questions on that? All right, let's move on. Do you want me to? I don't think I need the chart questions. Aren't those chart problems are pretty easy, aren't they? All right, let's talk about the ones where you have a what do you call those? A tree diagram. Yes, I think I did one last hour. There we go. Here's one that's all done. So here's a tree diagram, and sometimes we give you the tree diagram, and sometimes you have to figure out how to make it. And to make them, I think most of you guys will do fine on making them. Here's the hard part. The part you probably stumble on, if you're going to, is a question like this. What's the probability of getting a boy and a girl in any order? Don't say it. Write it on your iPad and then turn it my way. I'm going to say it again. Probability of getting a boy and a girl in any order. Now, don't overthink this about like where is it overlapping and all that stuff. Just they got to get a boy and a girl in any order. A boy and a girl. Boy and a girl. Oh, every single person that turned their iPad my way had it right, so I think that probably was too easy. But good job. Add these together. Because this is boy and girl, and so is this boy and girl. All right, so now here's the harder kind. That might actually be hard. Try it. Given that you have a girl first, what's the probability that you'll have a girl then boy? Given that you have a girl first, what's the probability you'll have a girl then a boy? When you have a given, I strongly recommend you have a denominator. Seeing different answers, but it's mostly due to rounding, so that's good. Actually, divide them. Divide them with a calc and see what that comes out. All right, nice work for a lot of you. I'm still waiting for a few of you. Got to slide it so he's right in the middle of his back. All right, good, thank you. All right, there's a few people who are off a little bit, but almost everybody had it. 0.52 or 0.519, which of course would round to 0.52. Okay, how does that happen? I would do it this way. I know there's one way that's super simple, but it won't always work. This way will always work. Girl first meant that we went down this road right here. So only those two things are possible. What are you supposed to get when you add 0.249 and 0.230? You're supposed to get that. If you're off by a teeny tiny bit because of rounding and then it says 0.479 instead of 0.480 or something, that's fine. That's supposed to go on the bottom. And what goes on top is what I wanted. Girl, then boy. That would be this one on top, 0.249. And then when you divide them, you actually get 0.52 or 519. And that's right here. That's the super simple way, is think, okay, I already walked down this road. I went for sure this way. Then my only two things that can happen are this or this. So that was the answer. But that doesn't always work. What will always work is add up what's possible, put it on the bottom, and then figure out what you want and put it on top. All right, I'm going to do one more question off of this. What's the probability, given you know they had a boy, you don't know when they had the boy, first or last, you know they had a boy, you see, got a glimpse of the kids getting in the car, and one of them was a boy. What's the probability it was boy, boy? And no, the answer is not just 0.270. What's the probability, given that you know they have a boy? What's the probability it's boy, boy? What you should have started with is, okay, I know they had a boy, so all the boy ones have to go on the bottom. That one has a boy, that one has a boy, and that one has a boy. Okay, and there's a faster way to do that. Instead of adding up those three numbers, I can take 1 minus 0.230. And that one's going to be 0.77, goes on the bottom. And if you're off by 1 just because of rounding, that's okay. Don't freak if your number's off by mine by a teeny bit. Then what's on top is what I wanted, which was boy, boy. That's the 27. So there you go. 27 over 77, which comes out, is that right? 352? 351, 352, okay. All right. Okay, any questions on that one? All right, these are some of the harder ones that people got wrong last time. Okay. Let's do, on the middle test, that I just don't want you to, even though most of you guys did really awesome on that, I don't want you to forget how to do like a warranty problem. So let's do one of those. Everybody try this warranty problem yourself. I don't want to explain it too much because you should be good at these. It either works or it breaks. This is a $1,000 TV with a $80 warranty. You find out that 30% of these TVs are breaking, which, by the way, means that the warranty is probably a good idea. Then figure out for me, if you're paying $80 for the warranty, what's your expected value? Figure it out. I'm going to pause for a second while you work on that. Here we go. Works probability. 70% chance it's going to work. 30% chance it's going to break. This is P times A, and then we're going to do what after that? Add. P times A, then add. Okay, the amount I get if it works, you walk in with your TV and say, my TV works. They're going to be like, so get out of here. You don't get anything. If you say, my TV broke, they actually owe you something. They owe you the money back on the TV. And again, we make these simple. In the real world, they just repair your TV, which is cheaper for them than spending $1,000 to give you all your money back. Okay, definitely a better deal if you can get a money back deal. Okay, then you go, this times this makes 0, and this times this makes 300. And therefore, this warranty is really worth 300. What number have I not used yet? The 80. So I subtract off the 80. Got to use that 80, otherwise you're going to screw this up. And then $220 is your expected value. This is one of the rare times when, because the break percentage was so high, you'd actually, on average, make $220 by buying that warranty. What if they said, what's the store's expected value? Negative 220. So they shouldn't, from the store's perspective, they shouldn't have sold you that warranty. They're going to lose money. They should have let you buy the TV and have it break because it'd be cheaper for them. In the real world, though, if you have a store, they don't want to have a bad reputation for having crappy products, and so might actually be some downside to letting people lose a bunch of money on the TVs too. All right, now let's talk about, we've done expected value there. What about an expected value where it's like you get an amount for rolling certain things on a die? Let's say we're going to play a game on a die. You roll a die, and if you roll a 1, you get $1. If you roll a 2, you get $2. If you roll a 3, that you get nothing. You roll a 4, you get nothing. You roll a 5, you get $5. And you roll a 6, and you actually have to pay out. You lose $6. Okay. So if this game was free, would you pay it? Would you play it? So it's interesting. You think it might have an expected value of 0 then, or even negative. Figure out the expected value for this game, and then I'll tell you how much it costs, and you can use that to recalculate your expected value. For right now, it's a free game. Is it worth playing? Figure out the probability times the amounts. Figure out your total. Remember, it's a 1 in 6 chance of rolling a 1, or a 2, or a 3. Okay, so it's a 0.16 chance of getting $1, and that's going to be 0.16. It's worth 16 cents. 0.16 times the $2. I don't know, maybe you had a longer than 0.16. Maybe you didn't round quite that much, but that would be about 32 cents. Did you go with 33 or 34 or 33? Okay, because I rounded it a lot. And then the next one, why am I not even going to have to do it? 0.16 chance, and I get 0 if it happens. So timesing by 0 is 0. Same with this next one, because I'm timesing by 0. And then the last one's 0.16, $5 for that one. That's starting to be worth something more. How much is that one worth? 80. And then the last one is worth negative something. You're going to lose $6. 0.16 chance times $6. Negative 6 is what I'm going to lose. So it's negative what? 96? All right, add them all up. P times A, then add. Is it still worth something? So it came out positive. Well, what did it come out positive what? 33 cents. So if it was free to play, you should play all day. Because on average, you're going to win 33 cents each time. Now, it may not be big money, but at least it's tilted towards you. Most casino games are not. So in the casino, you'd probably have to pay 50 cents to play. So then what would I do to recalculate it if I pay 50 cents to play it? Subtract off the 50 cents I have to play, and now I'm going to lose 17 cents, I think. Yeah, 17 cents each time. And they just do that except with bigger numbers. So they'd probably have a game in the casino where you get $1, you get you get $10, you get $20, you get $50, or you lose $60, and it costs you $50 to play. And then everything would move over a decimal, and so they'd make on average $1.70 every time somebody played the game. And then they just rack that up times a lot of people and a lot of time, and they make lots of money. All right, that's expected value. Let's talk now about VINs, because you guys did really well on the VINs part, and I don't want you to lose that. So say you got a triple VIN, A, B, C. I can give you ones that are tough though. If you're making the VIN, do you remember how I suggested you always start in the middle? So let's say that they give you the middle number and it's like an 8. Okay, then here's the part that people get confused on. If I say A and B, does that mean the blue circle or does that mean the black circle? A and B, is that the blue or the black? The blue one. A and B means both those areas. A and B. If this was aardvark and this was beluga whale, have you ever seen an aardvark or a beluga whale and you ask these people, they'd say yeah. They just have also seen a chipmunk. All right. You ask these people, have you seen an aardvark and a beluga whale? And they'd say yes. So they both are a and. Okay, so and is both of those. But here's the thing. People will get confused in it because it'll say aardvark and beluga whale is 10. And they'll go, okay, 10. Why is that wrong? Because you already had an 8 in there. So it should be a 10. What should it be? A 2. So be careful with that. Okay, so then I'm going to put in a bunch more numbers here. 1, 3, 4, 1, and 2. Okay. So, oh wait, we got an empty spot. Gotta have something in there. 2. So what's the probability of A and B? I'll help you add them up because I know it's a pain from a distance. It's 10, 15, 20, 23. 23 possible. What is the probability of A and B? You're going to pick a person and they have seen an aardvark and a beluga whale. Well, I got it circled already. It's 8 and the 2 makes 10. Raise your hand if you had that one right. Okay, good. Next one. This is going to get more complicated, of course. Given that the person I pick has seen a chipmunk, what's the probability they've also seen an aardvark? Given that they've seen a chipmunk, what's the probability they've also seen an aardvark? All right. Given that it's a chipmunk, do you get right away? You should make the denominator. And the denominator is 8 plus 2 plus 4 plus 1, 15. Raise your hand if you had that part right. Okay, good. Then, if you've also seen an aardvark, have these people seen an aardvark? Have these people seen an aardvark? So I put them together and I got 12. Not necessarily like face to face. Whatever. I just made up the numbers, but yeah, you get a point. All right, let's move on. Let's talk about today's test, the one you just took. Is there any of those you want to have me practice with you, like the kind where you do CC over C, or the kind where you do your binomial deal? You know, the C with the 2 parentheses? Either of those ones that we want to review, or do you not need those? I'm fine with whatever. Okay, nobody's asking. So I don't want to waste your time. This is the part where you guys can ask me questions one-on-one, and I will be glad to help you. All right, that's all I got for the video. To be